So to start with, this is the ecosystem or of Giotto. So these are the modular packages that Ruben introduced a little earlier. Um, we have multiple R packages that each provide slightly different functionalities and that also provide users with a fully integrated spatial omics workflow. So at the very base is Giotto Utils, which is a package that makes available a lot of different utilities that we use across all of our different modules. This usually has to do with things like message and print formatting, if deprecation code goes in here, and also code wrangling, seed setting, that kind of stuff. And then we also have Giotto class, which is basically the core definitions for all the methods and also the data structures that we use inside of Giotto. And it also contains some interoperabilities, mainly for things like Seurat interoperability, SquidPy, Spatial Experiment. It's really like what makes the Giotto objects act like Giotto. And building on top of Giotto class, we also have some example data sets and analyses, which I'll touch on in a slightly later step. These contain like data sets and some pre-worked analyses. And then we also have the core plotting framework. So these are like functions that are mainly used for spatial plotting and dimensional plotting. This all lives inside of Giotto visuals. It's a lot of code in there. And the umbrella package itself is building on top of Giotto class and Giotto visuals and utils mainly. But this basically is what utilizes the Giotto modules in order to do bioinformatic analyses. So filtering, normalization, spatial analyses, dimensional reduction, data integration, higher level functions and capabilities are stored in here. And each of these modules also has their own web page, which a lot of them are probably better geared just for like devs. We will probably talk more about this on day 3 when we talk about contributing to the package if people are interested. Okay, to start is installation. So Giotto installation, there's a lot of different prerequisites. It's getting Giotto installed and it can be a little bit tricky. More about this is already detailed inside of section 2 with needed packages 2.2 over here. It also has like more specific information and links to look at, but these are kind of like the highlights of what's listed in there. So it is an R package. So for Windows, R tools is gonna need to be installed. And then a major dependency, Terra, which is a geospatial, large geospatial package that works with both raster and also vector data. We use it for a lot of our subcellular information. And that has a lot of dependencies for your system. GDAL, Geos, Proj, and SQLite 3. These are probably not going to be as much of an issue if you're running on either Windows or Mac, because I think those are mostly bundled with the Terra installation nowadays with CRAN and also RUniverse. But if you're working on a Linux or like a HPC, then you are going to need to have these pre-installed somehow before you can install Terra. And after that, those are kind of like the main prerequisites. You are able to directly use pack to install Giotto. This should be a pretty convenient single-step process. It should also install all of the dependencies and the other Giotto modules that were mentioned earlier. This is also probably going to be easiest on 4.4 because that's the most compatible version right now, R 4.4. You can also install from the dev branches of the Giotto packages. So for each of these individual modular packages, we have a dev branch so that we don't push everything and like have non-working code living in the production branch. So for Dries Lab, it's all under our repository Dries Lab, and then after that, it's the name of the actual modular package, and then after that, it's the particular branch name after the @ symbol. So you would basically replace one of these inside of here to install one of the dev branch modules. So that's DevTools install GitHub. This is just easier than installing with pack because pack tends to enforce installing of all dependencies. And the way we've got things laid out right now, it's going to try to pull even the master branch from like a branch you might have already installed for the dev. But yeah, this is what you would want to run if there's like a dev branch function that is particularly interesting to you and you want to try it out. So common install issues. These are just some possible gotchas that you might come across. If you're installing on an R version before R 4.4, Pack can throw some weird errors when installing Matrix. We've heard like it might say you need R 4.5, which doesn't even exist yet, in order to install Giotto. And that's very strange. But I think the main reason behind that is just that Pack is throwing a strange error when looking for a matrix that is packaged from their currently released version that's actually compatible with 4.4. But if you're on a previous version, that's just not going to work. So what we do to get around that is to first install a previous version of Matrix 1.6-5, and then that should satisfy that requirement and allow you to directly use Pack again. And also, this is probably an error that you might come across, not even just in Giotto, but like across several other analysis packages, such as Seurat or the bioconductor packages. If you see this, it's usually related to an issue with Matrix and IRLBA. So if you come across that, then installing IRLBA from source should also resolve that. So that was the R installation instructions. And moving on to the next section, it's the Python environment installation. So we provide a convenience function in order to use a lot of the Python packages that Giotto uses for some of the most important things that we do. The first thing to do after installing Giotto for the first time is to create a Giotto Python environment. And Giotto has the following convenience wrapper. Install Giotto environment around some reticulate package functions in order to set up a default environment. So just in general, like some background for people maybe not familiar with Python, two things are needed for a Python installation to work. You need both a conda binary, and this can be either a mini conda, which is what we usually try to install by default, or an anaconda environment or an anaconda binary. And these are installations that provide the package and environment management systems for Python. And then after that, you also need independent environments with specific versions of the Python language and associated Python packages. So install Giotto environment, we'll check both of those two items, and then also install miniconda using reticulate if you need it. If you already have a specific conda binary that exists and you want to use it, it's very similar to how reticulate deals with it by default. You would set like conda param in a lot of the installed Giotto environment or a lot of the other parameters in Giotto, or you can also set the reticulate option. Reticulate.conda binary is to your conda path or the system environment reticulate conda. So after ensuring the conda binary actually exists, the default Giotto environment is installed, which is a Python 3.10.2 environment. And that's named Giotto env by default. So this is going to contain several default packages that Giotto installs, which are pandas, networkx, Python igraph, Leiden, which is particularly important because this is the default algorithm we use for Leiden clustering in Giotto. And then Python Louvain, Python app if needed, and scikit-learn. You can also make custom Python installations. This can be done by first setting up a new environment and establishing the name of the environment and also which Python version you want to use. So that's just done with reticulate conda create. You would set your env name and then the Python version, and then you would install one or more Python packages by using reticulate py install. Use env name to point it towards the one that you just made, and then you would list which packages you want. And once a environment has been set up, Giotto can hook into it. So how exactly using Python environment in R works is that R does all of this the reticulate package, which sadly only allows one environment to be activated per session. So that just prevents like a little bit of a difficulty. But the main thing is about how to select which particular environments you want to use at the start of the session. The way that Giotto activates a Python package it does it when any of the following happens. So the first time that you create a Giotto object in the session, or the first time you create a set of Giotto instructions, which I'll touch on in a sec. And the most straightforward method is probably just Giotto class, set Giotto environment path. And I can just do a quick example of some of those. I think this is like a fresh session at the moment. If I library Giotto, I'm just gonna load it in. And the first time I make a Giotto object, it's gonna set an environment for me, and the default is, of course, pointing towards Giotto env. It would also do the same if you were to create an Giotto instructions, or if you were to set a Python path. And here you can actually specify more Python path that you want to use. You could also have done the same with the instructions. Which environments is activated is usually based on a set of 5 defaults in decreasing priority. So when you provide a particular path with the Python path param that I just mentioned, that's available through, again, this particular function, set Giotto Python path, when you first create the instructions, and either of those really, and also a lot of the Giotto creation functions. But if either a full file path or an env name are accepted, and any provided path or environment name set in options, Giotto.pypath will also be set as the default. So that's a very convenient one to use. And then third on priority list is going to be the default expected Giotto environment based on reticulate minikana path, and then it's going to check Giotto environment as the expected name. And lastly, it's going to check for what default Python environment would be on the system. So method 2, this one, is most recommended when there is a non-standard Python environment that you regularly use with Giotto. One way that you can do it is by running fileedit.r profile, and this is just like a script that runs at the start of every session, and you could add in the option to set this particular path so that it's already active in your session when you first open it up. If it's a specific environment that you would only want to use a couple of times, then method 1 is probably going to be easiest. So this is when you specify a particular path to Python path. And also to check which conda environments exist on your machine, so you can see like which env names are actually available, you would run reticulate conda list. I think most of these, that was a lot of pseudocode earlier, so I was showing it in this the rendered web page, but now I'm gonna move over to here. Mostly because like the following parts can actually run more directly. Just to show, this is like a list of both what name each of these environments have, and also where you can find their full binary paths. And once you activate an environment, you can also check for more details and ensure that it's actually the one you're expecting by running pyconfig. And I already activated it earlier because I ran Giotto, and it does point towards Giotto env right now. And it is indeed 3.10.2. Okay, next part is about Giotto instructions. So Giotto uses the Giotto instructions class or to set a behavior for particular Giotto and object analysis object. Sorry. Most commonly used are these params over here. So you have Python path when you set that particular environment. Yep. And then save directory. This is an option that you set for telling where plots that are generated should go to. If you make it so that you only save the plot and you never actually return or show it, then it actually is a lot faster because the R viewer over here can tend to be a little bit slower than just saving the plot to disk. So that's something that we tend to mention because it speeds things up. And save plot, the save return plot and show plot, these are just Boolean or logical settings for how your plots should work. So whether to save plots to the save directory, whether to actually return the plot objects, because a lot of these plots are going to be ggplot2 objects when returned. When you set to false, only null is returned instead of the ggplot object. And then show plot is whether to actually show it in the viewer. So you can create one of these objects with create Giotto instructions, and the created objects can then be edited using the instructions generic function. So I already libraried, but to set the save directory, and then just to create one of these instructions objects. So this is what it looks like inside. It's really just like a list with a couple of settings inside of it, and also the class Giotto instructions. Giotto object creation functions all have like an instruction param where you can pass in this object that you just made, the Giotto instructions object. And the Giotto objects will also respond to the instructions generic, which is a convenient way to access and modify your instructions information. So let's see. What is this? This is making a new Giotto object with the instructions param, allowing passing through that instructions object we just made. So the test is just an empty Giotto object. And then that's just an example of how you can do that, really. You can see that instructions of test will then pull out that exact object we just made with the settings that we set earlier. And here is just an example plot. So I'm going to pull out a pre-made object. I'm going to put in the instructions object we just made. And then after that, I'm also going to say, or I'm going to check what the setting is right now for show plot. That's something that we set earlier up in this step. I'll just close this with show plot equals false. So right now it's not supposed to display it to viewer, and instead it's going to write directly to disk. If I go there, yeah, that's where it showed up. Did I just make this? Yeah, this one. So this is the one that just showed up in there instead of showing to viewer. That was the applying function I just ran, where it went directly to the results folder. And then if I wanted to actually show it to viewer as well, I would say show plot true. And then it should actually display. So it's showing up over here because this is a markdown. And that's it for this particular session.